Okay, this is going to be a quick review of Investigation 2 for swingers. Do not just use this, also use the study guide that we went over in class. But this should kind of help you review what we conducted in class in terms of experiments. Now, at the very beginning of this investigation, each class had to design an experiment. We made pendulums, which were strings attached to pennies and paper clips that swung off of a pencil. Now, some of the things that as a class we had to decide was first what we were going to test. And actually I told everybody we wanted to find out how many swings a pendulum would make in 15 seconds. Now, some of the things that we had to decide before conducting the experiment so that we could all really test it were, one, what was a swing? And so some classes decided on one thing, others decided on the other, but later on we all decided that a swing would go forward and then backwards, and that would count as one swing. So that was one of the variables that we had to determine before conducting the experiment. In addition to that, we had to decide on a release point, and we all released our pendulums at exactly 180 degrees or 0 degrees, parallel to the ground. Finally, we all decided, or Miss Tom told you, that we were going to be counting the number of swings in 15 seconds. So those three variables we decided as a class. You could also consider the fact that everybody used pennies and paper clips as the bob at end. What is a variable exactly as a review? A variable is anything that can change in an experiment that might affect the outcome. Now, we learned through our readings that Galileo tested a lot of different variables, and some of those things that we controlled in our investigation didn't actually affect the outcome for Galileo, but it's still important that we controlled them because we weren't sure. So, here's some of the variables that we looked at. Like I said before, the release point or position, the amount of time in which we counted the swings, in this case it's 15 seconds, the mass of the bob at the bottom of the pendulum, we used a penny and a paper clip, and then finally later on, we also looked at the length of the pendulum and how that affected the number of swings. Now, in our investigation, these four variables, can be divided into different categories. Every single group or pair looked at these variables and said, are they going to be the same as the other pair or another group, or are we going to be different? Well, the release point was the same for everybody, so that would be a control. Same with the amount of time. Everybody counted number of swings in 15 seconds. That's a control as well. The mass of the bob, everyone used a penny and a paper clip, so that was a control as well. But finally, the last one, the length of the pendulum, later on, we learned that that actually could really affect the outcome. And so we wanted to discover a relationship. We found that kids who had pendulums that were 200 centimeters long versus kids who had pendulums that were 10 centimeters long got different outcomes. So because each different pair or group had a different length pendulum, that's our independent variable. What relationship did we discover exactly? Well, we graphed this by hanging up the pendulums next to each other based on the number of swings. We found out that the longer the pendulum, the fewer the number of swings. So when we hung all of our pendulums up, it started looking a little bit like this. Now, obviously, the pennies were all still the same size. They didn't get smaller, but unfortunately my computer program does not recognize that. So the pendulums look like they're getting significantly smaller as well. Oops, that one's a little bit shorter. So we found that there was a kind of curve going along. As pendulums got shorter, the number of swings got greater. going to just review those two concepts and how they relate, that relationship. We know the shorter the pendulum, the greater the number of swings. And the longer the pendulum, the fewer the number of swings. And we could see that with our graph. Now the graph that I just showed you, I'm going to go back, okay, had our dependent variable, the number of swings, the outcome that we could not control, on our x-axis, and the length of the pendulum, our independent variable, on the y-axis. This is because we hung it off of the whiteboard and we had to do it this way. However, when you are graphing your results, you want the length of the pendulum to be on the x-axis because it is your independent variable. Independent variables go on the x-axis. Dependent variables go on the y-axis. So we're going to extend this to another situation that's on your study guide, and it's Bob's tree. The numbers are a little bit different, okay, but it's the same idea. Bob planted a tree in his garden, and he decided that he would go outside and check it once a week for 4 weeks and measure how tall it was. So it ends up being that our independent variable, because he chose when to go check it, is time. So we're going to put that on our x-axis. In this case, it's in weeks. He could not control how tall that tree was going to be, okay? So that was our dependent variable, the height. Now looking at the data to the right, he found that on week 1, his tree was 20 inches. Oops, I forgot to label a couple more things on my graph. Okay, so I have time in weeks. He measured for week 1, 2, 3, and 4. So I'm going to put those numbers on my graph. Okay? Now I also need to put height in inches, and every single step needs to be the same interval. So say I'm going to start with 0 down here. When I go from 0 to the next line, I'm going to make that 10. And because I made 10 from 0 to 10, I have to count by 10s for the rest of the way. So 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Notice I'm always counting by the same interval, by 10s. Sometimes you can do it by 5s or 2s, but it has to be the same way each way. Okay, now that I have my numbers, I can go back. On week 1, the tree was 20 inches. So I'm going to go to week 1 and 20 inches and put a little dot there. On week 2, it was 30 inches. So I'm going to go to week 2 and 30 and put a dot there. Week 3, it was 40 inches. And week 4, 45. So because it's 45, I'm going to have to go exactly halfway between 40 and 50 and put a dot right there. And I can connect it and notice that the tree got taller each week, but not quite as much taller from week 3 to 4 as between the other weeks. Okay? So that is one extension we could have from our pendulum experiment in terms of understanding independent and dependent variables. On your study guide, there is also an idea about testing tire swings. I'm not going to go through this, but I want you to make sure you check over your study guide. If you wanted to test the number of swings the 2 tire swings of different lengths would make, you can also design an experiment. It is very, very similar to the pendulums. Keep that in mind, okay? Or take a look at the study guide key on the internet and check out what we discussed